Hello again, students. In this video we are going to continue with the topic of finding the value of missing angles, but this case we are going to include equations in them. Okay, so let's begin by the example B, because we have previously done A. So let's begin. Let me select the pencil. Yeah. Okay, here we have that these two angles, they are adjacent and they form together a 90-degree angle. So we know that 90 degrees minus 48 degrees is equal to 3b degrees. Why? Because you know that if you subtract 90, which is the totality of this, with the 48, what remains is 3b. Okay, so in this case we just have to solve this equation. Okay, and if you by any case you don't remember how to solve equations, well, the idea is to leave alone the variable or the incognite. In this case we can solve this right away. 90 minus 48 is just 42, so this is 42 degrees equal to 3b degrees. And if we want to leave alone this v, let's remember that between these two, well, between this 3 and this v, there's multiplication, because whenever there's no operation expressed, it's because it's a multiplication. So here's a multiplication. How do we get rid of a multiplication? By dividing in both sides. Okay, so we divide by 3 in this side, and we divide by 3 in this side. Okay, so what is 3 divided by 3? Well, it's 1. So these two cancel, sorry. So this is basically b in this case, and 42 divided by 3 is 14. Okay, so we found that angle B is 14 degrees. Okay, and this is the basic idea for all of these exercises. We have to be able to propose an equation that we can solve. For example, in this case, okay, we have C and 2C. Okay, remember, if we are using the same letter, that means that it's the same value. Okay, even if right now we don't know how much is C, we know that this C is going to be the same that this C. Okay, take that into account. Okay, so what can we do? Okay, we know, for example, in this case, that these two angles are the same, this angle and this angle. Why? Because they are corresponding. Okay, so we can see that in this case we can also write 2C here. Okay, so C and 2C are adjacent. And remember, kids, what do these two angles have to add up to? 180, because they are adjacent and they are on a straight line. So 180 has to be equal to these two things. Okay, C plus 2C. Yes, so can we simplify this? Of course. If here we have C and here we have 2C, in actuality we just have 3C. Okay, 3C equals to 180 degrees. Okay, and we get something similar to what we had in the previous exercise. We have to get rid of this 3. So if this 3 is multiplying, we get rid of it by dividing. Okay, we divide by 3 here and we divide by 3 here. Okay, so this 3 cancels with this 3, so here we just get C, and 180 divided by 3 is 60. Okay, so now we found that the angle C is equal to 60 degrees. Let's continue with some more exercises. Okay, here. Anyway, let's do this one using equations. Okay, so you know that all of these has to add up to 360. Okay, but is there a way that we can express just A, or these two angles that are A and A? Well, yes, because these two angles are 2A. Okay, and we know that if we have 360 degrees and we subtract 90, we get this 2A. So it's 360 minus 90 is the 2A. And 360 minus 90 is 270. So 2A is 270. Remember, we want to leave the variable alone. Well, let's divide in both sides by 2. This cancels. And 270 divided by 2 is 135. Okay, so A in this case is 135. This is 135. This is 135. But now let's introduce a little higher level of difficulty. It's not so much, don't worry. Okay, so remember, kids, here we have two co-interior angles. You know that these two should add up to 180, but if you don't remember that theorem when you're solving an exercise like this, you can remember that this D is corresponding with this angle, so that means that it's the same value. Okay, and now you know that these two adjacent angles have to add up to 180. Okay, so we can write that 180 has to be equal to the combination or the addition of these two. So it's D plus, let's write it without the parentheses, D plus 80. Okay, look, this is this one, and this is this one, and they together combined have to add up to 180. Okay, so let's continue doing this. So 180. Can we simplify this expression? Yes, because we can combine these two D's. They are just 2D plus 80. Okay. Remember, kids, that when we are solving equations, the idea is to leave the variable alone. So we have to start getting rid of everything that is not the D. Okay? So in this case, we do not get rid of the 2 because it's really, really close to the D. So we leave it to the end. But we can get rid of this 80. If this 80 is positive, it's adding, the way to get rid of it is by subtracting it. So it's 2D plus 80 minus 80. That makes these two things to cancel each other. But what happens that if here we subtracted 80, in the other side we have to do the same. Okay, subtract 80 again. Yeah, you see, if we did this here on this side, we have to do the same here on the other side. Okay, so 180 minus 80 is just 100, and this is just 2D. Okay, because these two cancel each other, they are gone. Okay, now we know that 100 is 2D. Okay, let me write it again. 100 degrees is 2D degrees. How do we get rid of these two? Once again, divide by 2 in the side, and the same in the other side. These two cancel each other. This is just d, and 100 divided by 2 is 50. Okay, 100, sorry, d is 50 degrees. Let's continue. This is something similar. So here, in this case, we already have the two adjacent angles expressed. You know that these two angles together have to add up to 180 degrees. So, the same. 180 degrees is equal to the addition of 2x plus 3x plus 5. Okay? Can we simplify this expression? Yes, because we can combine these two like terms. If here we have 2x and 3x, in total we have 5x plus 5. Yes, because this cannot be operated with anything. And 180 on this side. Now, how do we get rid of these numbers? Let's begin by the 5 degrees. So, we get rid of that by subtracting it. So, plus 5 minus 5. Okay, remember, this will make that this is gone. But if we subtracted 5 on this side, on the other side, we have to make the same. Subtract 5. Yeah? Well, 180 minus 5 is 175. And this is just 5x degrees, because these things are gone. Now, we get rid of this 5 by dividing by 5 on both sides. Okay, so 5 and 5 are gone, and 175 divided by 5, let me do it because I don't want to do it by with my mind. Sorry. Okay, 5 in 1 doesn't fit. 5 in 17 fits 3 times. 3 times 5 is 15. We subtract. The result is 2. We drop down the 5. 5 in 25 fits exactly 5 times. 5 times 5 is 25. We subtract and we get 0. So we finished. It's exactly 35 degrees. X is 35. Okay? Let's continue. And finish with this. Okay? So, here we have alternate angles. Okay? So, remember the theorems of the angles. Let's go back a little bit to one of the first slides of this presentation. Okay, this one. If you see the example, we have something like this. Okay, two angles that are alternate inside the parallel lines, but on opposites or in alternate sides of the transversal line that intersects with the parallels. What does the theorem says? So it says that when two parallel lines are cut by a third line, angles in alternate positions, which are like this, are equal. Okay, so what does it mean? It means that the two angles that we have in those positions are equal. And you may say, teacher, but this is not equal. Yes and no. It's written in a different way, but in actuality, the values that they represent have to be the same. Okay, so we need to assume in this case that x plus 10 is exactly the same that 2x minus 25. Okay, and solve the equation accordingly. Okay, we will find in this case that we have variables in two sides. When that happens, the idea is to move the variables to one unique side and leave the natural numbers or fractions or decimals, when whatever they appear there, in the other side. Okay, so here it doesn't matter where we decide to leave the variables. So let's say that I want to put this x in the other side. Okay, so whenever you want to move one thing, one term of an equation to the other side, you need to move it with the opposite sign. So if this x on this side is positive, because you don't see any sign before it, so it means it's positive, you can move it to the other side, but negative. Okay, so let's see. Let's leave this 10 on this side, but the x moves, so it's 2x minus x. Okay, remember, this x moved to the other side negative. Look at it here. Okay, and this negative 25 is going to move to the other side, but positive. Okay, because here on this side it was negative. So it's actually 10 minus 25. Okay, but let me write it properly, because if not, we are going to make a mess. So it's 10 minus 25 on this side. Okay, so let's solve it. 10 minus 25 is negative 15 degrees, and 2x minus x is just x. Okay, we have two x's, and we get rid of one. We are left with only one. So x is negative 15. We already solved it. Okay, so that's it. That's how you can start solving problems like this. Okay, so during class we are going to do the other exercises, and if you have any question, just say it to me during class or write a mail to me.